Okay, so we're going to start with a problem where we have the equation of a circle. We're going to put that equation into standard form. From that standard form, we are going to identify the radius and the center, and then we're going to graph it. And yeah, I've already cheated. We can see the graph of it right now, but that's because I'm using Desmos as a graphing tool to help us figure out what's going on. So this is our equation, x squared plus y squared plus 8x minus 2y minus 8 equals 0. And we can sort of say, okay, no more cheating. I don't know where that's supposed to graph. How are we supposed to know how to graph that thing? Well, step one is to put it into standard form. Okay, so here we want to graph the following equation, and we're going to figure out all the relevant information that we need along the way. So here's our equation that we just saw. X squared plus y squared plus 8x minus 2y minus 8 equals 0. By looking at it, I don't know where the center of the circle is going to be. I don't remember what the radius is. I honestly don't. But we're going to get there, right? So the first thing we want to do is organize this problem where we get the x terms together, the y terms together, and the constant is on the other side of the equal sign. So that's the very first thing we're going to do here, is go through and organize this equation a little bit better. See how on this line our x's and y's are all mixed up? Well, let's get the x's in front, the y's next, and then the constant is over by itself on the other side of the equation. Okay? That's great because the next step we're going to do is use completing the square on the x's. We're going to do completing the square on the y's, and then we're going to simplify everything. Okay, so here we go. Complete the square on each variable. So how do we do that? Remember about completing the square? So just ignore your y variables for a minute. Just pretend like they're not there. Okay, just focus on the x's. So what do? Okay, so I've got x squared plus 8x. See how I just brought these two terms down? You go, wait, where'd that 16 come from? Just hold on 1 minute. I've got my x squared and my 8x. So the rule for completing the square says you look at your x term, you take half that coefficient, and you square it. So half of 8 is 4. 4 squared is 16. So I'm going to add 16 right here. The whole reason we're doing that, remember, is to complete the square because we want this to factor in a minute. But if I add 16 to the left side of the equation, I have to add 16 over to the right side of the equation. So that's why there's a plus 16 on both sides of the equation. Completing the square said that I needed to add 16 to the left side, and in order to keep it balanced, I need to add 16 to the right side. Okay? Now we're going to ignore the x's, and we're just going to focus on the y's. So I look at my y's, and again I go, okay, completing the square says I look at the y term, I take half the coefficient and square it. So half of 2 is 1, 1 squared is 1. So I'm going to add 1 to the left side of the equation, and sure enough, if I add 1 to the left side of the equation, I have to add 1 to the right side of the equation. So that's how you have this plus 1. So the 8 was already there from our previous problem. The 16 came in when I added 16, and the 1 came in when I added the 1. Okay, so you can see everything's legit, right? Everything is following right from completing the square. Now, if we've done our work correctly, this trinomial in front is going to factor as a perfect square. This trinomial in back is going to factor as a perfect square, and we can simplify the right side of the equation. So let's do that. We're going to factor everything, and when we go through and factor everything, we're going to get the following. We get x plus 4 squared, right? That's this part factored, plus y minus 1 squared, that's this part factored, equals 25, that's 8 plus 16 plus 1. So all I did was just simplify each of these three parts. And then I can see here, if we go back to our formula for circles, that tells us that, remember we think of it as x minus. So if we think of this as x minus negative 4, that means that my center should be at negative 4, comma 1. So my center should be at negative 4, comma 1, and my radius should be the square root of this number over here, which is 5. So my center should be at negative 4, comma 1 with a radius of 5. Let's see if that holds up. So now I've already got this entered in here, right? This was the original equation we ended up with. Now here's a nice way to check your work. If I put our new version in there and they're the same graph, then I didn't make a mistake. If they don't line up right, then a mistake was made. So, they line up, so we know we didn't make a mistake, and according to this, the center should be at negative 4, comma 1. That looks right. Okay, and my radius should be 5. Let's see, if I'm at here and I go over 1, 2, 3, 4, 5, yeah, we got it, right? And same if you go up 5, over 5, down 5, it all works out. So we know we got the center, we know we got the radius, the circle works out, and we got it graphed.